You come home from a long, exhausting day at work. You're hungry, but cooking is the last thing on your mind. So you reach for a quick solution, a frozen meal and your trusty microwave. Pop it in, hit start, and wait. What actually happens to your food when it is microwaved? Is it being exposed to radiation? Are you zapping away its nutritional goodness? Why do eggs explode in microwaves, and what happens when you microwave an ice cube? Well, buckle up because we're about to answer all of your burning questions about microwaves. This unassuming box in your kitchen, seemingly just another appliance, is actually a marvel of modern science. Microwaves were invented in the year 1945 by Percy Spencer, an engineer at Raytheon. Yes, that Raytheon. One day, while working with radar magnetrons, Spencer noticed something odd. A candy bar in his pocket had melted, not from heat, but from the radar waves. And in 1947, they introduced the world's first microwave oven, although it was first called the Radarange. Radarang. It was a gigantic water-cooled behemoth far from the convenient kitchen appliance we know today. And through years of innovation and design, the bulky Radarange evolved. It shrank in size, became more affordable, and eventually found its place as a household essential. And so, the microwave oven, born from the crucible of war, became a symbol of peacetime convenience. But how does a microwave actually work, and what makes it so efficient yet so controversial? The key component of a microwave is called the magnetron. This is the part of your microwave that generates electromagnetic waves. But these aren't just any waves, they're specifically tuned to the frequency that excites water molecules. When you hit start on your microwave, the magnetron starts bombarding your food with these waves. These waves are absorbed by the water molecules in your food. And what do these water molecules do? They start to vibrate rapidly. This vibration creates heat. It's not the microwave itself that's heating your food, but the friction from these jostling water molecules. This is why foods with higher water content, like vegetables, heat up quicker. Unlike conventional ovens that heat food from the outside in, microwaves heat food from the inside out. This is why microwave cooking is generally faster and actually more energy efficient. Now that you know how a microwave works, let's bust some myths and address some legitimate safety concerns. First, it's crucial to understand what radioactive actually means. Radioactivity involves the emission of particles from the nucleus of an atom. This is not what's happening in your microwave. Microwaves use electromagnetic radiation, which is on the complete opposite end of the electromagnetic spectrum, compared to harmful radiation like gamma rays or X-rays. The electromagnetic waves in microwave ovens are non-ionizing. This means they don't have enough energy to knock electrons out of atoms and form ions, which is what ionizing radiation like X-rays do. Non-ionizing radiation cannot make things radioactive. When you're heating your food in a microwave, you're just making the water molecules move faster to create heat. There's no nuclear or chemical reaction happening. Your food remains chemically the same, just hotter. What happens when you microwave an ice cube? Contrary to what you might expect, it doesn't melt, or at least not as quickly as other foods. Why? Because ice lacks the water molecules in liquid form that microwaves typically vibrate to generate heat, so it melts slowly and unevenly. The concern with microwaving plastic is the potential for harmful chemicals to leach into your food. It's true that some plastics, when heated, can release chemicals like BPA or phthalates. However, not all plastics are the same. Always use containers labeled microwave safe. These plastics are tested to ensure they can withstand microwave temperatures without melting or releasing harmful substances. So the key is to use the right kind of plastic when microwaving your food. All forms of cooking alter food's nutrient profile to some extent. The reality is, microwaves often preserve more nutrients compared to boiling or frying, due to shorter cooking times and reduced water usage. So microwaving can actually be one of the healthier cooking methods. Microwave ovens are designed with shielding to prevent the microwaves from escaping. As long as your microwave is in good condition and the door seal is intact, virtually no radiation can leak out. So, standing in front of it while waiting for your popcorn is perfectly safe. Probably, because if your microwave is very old, the door seal could be worn off. So ditch that old Radarange you have been holding on to for that retro look. But if you have a newer microwave, you have nothing to worry about. With these myths busted, let's turn up the heat and dive into the real risks associated with microwave ovens. Are there any? Ever bitten into something microwaved and found it lava hot in one bite and ice cold in the next? This happens because microwaves heat food unevenly. Some parts of the food absorb more microwaves than others, leading to hot spots. To combat this, stir your food halfway through cooking and let it stand for a few minutes after microwaving. This allows the heat to distribute more evenly. Microwaving whole eggs can lead to explosions because the shell traps steam, causing pressure to build up and the egg to burst. You can microwave scrambled and poached eggs safely, using short cooking intervals. Avoid microwaving eggs in their shells, including hard or soft boiled, to prevent explosions. For eggs without shells, pierce or slice them first to let steam escape. Next, superheated water. It's a bizarre but dangerous phenomenon. When water is microwaved for too long, it can get hotter than its boiling point without actually boiling. When disturbed, like by adding a spoon, it can violently erupt. Always be cautious when microwaving water. Finally, the classic no-no, putting metal in the microwave. Metal can reflect microwaves, causing sparks and potentially a fire. Keep metal out of the microwave. This includes aluminum foil, utensils, and even containers with metallic trim. When in doubt, stick to microwave-safe containers. While these risks sound scary, they're easily manageable with a little knowledge and caution. A special thanks to Jewelry Outlet for sponsoring this video. Are you sick of buying fake jewelry that changes color or irritate your skin, while your grandparents' old jewelry still looks the same and is worth a lot more today? Check out jewelryoutlet.com for real gold, silver, natural and ethically sourced diamond and gemstone jewelry at outlet prices. Jewelry Outlet. Real jewelry, real savings.